Right, now we'll take a look to see how you would actually do the calculation to determine decibels of a sound. Before we do that, there is one thing I forgot to mention. Also, for further discussion of logarithms, there are 3 pages in your workbook, pages 134 to 136. There's a few more pages if you want to read some more about logarithms and what their meaning is and how they're used. So you can certainly take a look there. All right, now let's take a look at example 22.7 that is in the textbook, and that is at the bottom of page 450. So in this example, you are given intensity of a sound as 1 times 10 to the minus 4 watts per square meter as an intensity, and you are asked to calculate the intensity level, which would be in decibels. So here's our equation for calculating the decibels, which is the intensity level of a sound. So we were given the intensity of this sound, which will go in the numerator here, and the I subscript 0 is the hearing threshold, which is always the same. 10 times the log of 1 times 10 to the minus 4 watts per square meters divided by 1 times 10 to the minus 12 watts per square meter. Now you'll notice that the watts per square meter units cancel out, and what you're going to be left with at the end is what's called decibels. So what you're going to do is what order of operation. So you're going to do the calculation inside the parentheses first, and then once you've calculated what's in the parentheses, then you will use your log function on your calculator to take the log of what's inside the parentheses, and then you multiply by 10, and that will give your answer. So the first thing you would do is enter 1 times 10 to the minus 4 divided by 1 times 10 to the minus 12. And then, once you have that, press your log key on your calculator and then multiply by 10. So right now, before I multiply by 10, I have the number 8. Multiply by 10, and I get 80. So the answer is 80 decibels. Decibels is typically abbreviated lowercase d, uppercase b, decibels. Now there's another way you could do this too. Knowing the rules of exponents, you could just look at this number and say, okay, 1 divided by 1 is 1. And if I was to take the 10 to the minus 12 and flip it up into the numerator, that would become minus 4 plus 12, or 10 to the 8th. So everything inside the parentheses then simplifies to 1 times 10 to the 8th. Now you remember what we're doing when we take the log, the base 10 log of a number. You're trying to answer the question, which exponent of base 10 will give you that number? Well, you can already see what it is. It's 8. 8 applied as an exponent to 10 gives you that number. So the log of this number gives you 8. 8 times 10 is 80. So you can also do some of these calculations manually, and you might find it easier and faster. All right, the next, now that you've seen that, I did assign the other day worksheet number 1, which was starting on page 137, but there was one problem, number 5, in that worksheet number 1, which you weren't able to do because we had not discussed this material quite yet. So your next practice problem would be on page worksheet number 1. Worksheet number 1, page 140 in the workbook, problem number 5. What you're given is a sound with an intensity level of 3.5 times 10 to the minus 6 watts per square meter, and you are asked to calculate the intensity level in decibels. So this will be much like the one we just did. So the decibels, the intensity level in decibels will be 10 times the log of the intensity of the sound divided by the hearing threshold intensity. And again, the units cancel out. Again, you could do this manually if you wanted to. 3.5 divided by 1 is 3.5. And then also you could take the 10 to the minus 12, flip it up into the numerator. And so you're going to end up with, you could also do this in your calculator too. I'm just showing you that it can be done manually. So you end up with 3.5 times 10 to the 6th. And the units have canceled out. So you could just enter that in your calculator, 3.5 times 10 to the 6th. Take the log of that number by pressing your log button, and then you would multiply. Don't forget, once you've taken the log of this number, then you still have to multiply by 10 to get decibels. And I got about 65.4. All right, so you just have to keep practicing to make sure you can work your calculator to get that result. So here are some problems to practice out of the textbook. These are at the end of the chapter, starting on page 460. Problems 22.16 and 21. Now there is another type of problem which is slightly more advanced. The more advanced kind of problem would be, what if you were given the intensity level in decibels and then you were asked to use that to calculate the intensity in watts per square meter? So let me just quickly give a couple of hints of that. So it's the same equation. Same equation, and you kind of have to work it backwards and in reverse. One of the hints is that you remember we said on your calculator you'll see a log button, and right above it there should be a shift function 10 to the x. And these are inverse functions. So for instance, just like if you have an equation like this, a equals b times the square root of c, if you were asked to solve for c, you have to find some way to get rid of the square root sign. And you do that by doing the inverse of taking the square root, which is squaring. Same thing with this kind of an equation. The way you would get rid of the log function is you would do the inverse, which is 10 to the x. So we can just do a quick example. What if you were given an example? Let's say you were given a sound has an intensity level of 120 decibels, and you were asked to determine this in the intensity of that sound in watts per square meter. So you need to get this I all by itself. How do you do that? So first thing you would do, just using your algebra skills, divide both sides by 10. And then over here you can simplify this expression. 120 divided by 10 would be 12. So now we've simplified it down to 12 is equal to the log of I over I0. So now we get rid of the log function. If we do 10, base 10 with this being the exponent, 10 to the x, and then we do the same thing over here, that serves to eliminate the log function. So over here we now have, we'll write it a little neater. So right now we have 10 to the 12th equals I over I0. So now all you have to do at this point is substitute in the 1 times 10 to the minus 12 watts per square meter, and then you just solve for I. I at that point is the only unknown. So that kind of gives you some hints of how to go about that if you run across that kind of a problem. All right, so that's it for section 22.5, and there are the practice problems.